There's a couple of methods of factoring trinomials. We're going to show the trial and error method right here. There's another method called the AC method, which is shown in the book, but what we're going to do is use this trial and error method. If we want to factor x squared plus 7x plus 12, we know if it factors, it will factor into the product of two binomials such that the product of their first terms has to give us x squared and the product of their last terms has to give us 12. So if I use x and x for the first two terms, I get x squared. Now there's a lot of ways to get 12. Let's try 2 and 6. 2 times 6 will be 12. Now if I check my middle term, here's 2x. Outside is 6x. And there's no way that I can take a combination of 2x and 6x and get 7x. So that means that 2 and 6 will not work for the second terms. So I'm going to erase them. Let's try 3 and 4. 3 times 4 is 12. Inside I have 3x. Outside I have 4x, and you can see that 3x plus 4x is 7x. I want my 7x to be positive, so both my 3x and my 4x will have to be positive, so those two signs will both be plus signs. Now, we never need to make a mistake with this factoring because we can always multiply these two binomials back out and see if we get this trinomial we started with. X times x is x squared, positive 3 times positive 4 is positive 12, inside is 3x, outside is 4x, and they add up to 7x. Let's try another one. Trinomial I have here. If it factors into the product of two binomials such that the first two terms in each binomial must multiply to give me x squared, the last two have to multiply and give me 12, and the combination of the inside plus the outside has to add up to this coefficient negative 1 right here. Or it has to add up to this middle term, negative 1x. How about if I try 4 and 3? 4 times 3 will give me 12. Inside is 4x. Outside is 3x. And I see that if I subtract these two, I can get 1x. So if I subtract them, I get 1x. I want that to be a negative 1x. So I'll make my 4x negative, and my 3x positive. The 4x came from the product of these two, so I'll put my subtraction sign here. The 3x came from the product of these two, so I'll put my addition sign here. Now let's just check the last term. Negative 4 times positive 3, that gives me negative 12. So if I multiply this all out again, I'll see that I get x squared minus x minus 12. Now, if a trinomial like this factors into the product of two binomials, those two factors that you get are unique. You don't have to look for two other ones. Once it factors one way, that's the only way it's going to factor. Here's another problem. 2a to the 5th, 4a squared b, 4a cubed b squared. The first thing I want to do on any kind of factoring is factor out the greatest common factor. In this case, that will be a 2, a cubed, and I think that's it. When I take 2a cubed from each term by factoring, what's left here is a squared plus 2, ab plus 2b squared. Is that right? When I factor a 2 from this, I end up with 2 right here. Yes, that's right. Now, if this is going to factor further, it will be 2a cubed times the product of two binomials here, such that when I multiply them together, I get this. Now, you can try all you want, try all the binomials you want. This happens to be a prime polynomial, so it does not have any binomial factors. So this is as far as we can factor with this problem right here. So that just goes to show, and you can try this yourself, but what it shows is that not every trinomial is factorable. Here we have one that's not, and we call it a prime polynomial. Let's look at our next example. 10x squared minus 3xa minus 18a squared. Okay, I look for a greatest common factor for each term. There isn't any other than 1. So if this factors, it'll factor into the product of two binomials such that when I multiply the first two terms together, I get 10x squared. When I multiply the last two terms together, I get 18a squared. So let's try 5x and 2x, because 5x times 2x is going to give me 10x squared. And then let's try 3a and 6a, because 6a times 3a is 18a squared. Okay, inside I would get 6ax, outside I would get 30ax, and there's no combination of these with addition or subtraction that's going to give me negative 3 AX or XA. So let's reverse these. Let's make this 6A and let's make this 3A. That product, 6A times 3A, is still 18A squared. Now inside, 6A times 2X is 12AX, and outside, 5 times 3 is going to give me 15A times X. Okay, well those do differ by 3, so if I make this negative and this positive, when I add them, I get negative 3AX. So I do get that correct middle term. So 12AX, let's see, that came from here. I'll make that positive. And the 15 came from these two, so I'll make that negative. Let's just check our last term. Positive 6A times negative 3A, that is in fact negative 18A squared. So this factors in the way that the first two examples factored with this trial and error sort of method. Now the more of these problems you do, the better you're going to get at it.